Alright, hell yeah. So what we have here is the math section of the JEE Advanced 2024. And hell yeah, I was able to do this one. Now, I've already done it, and it's kind of a bummer that I pulled these where like they already give you the answer. But, I mean, I don't think that's really going to help you if you don't even know what's going on. So, you know, when I looked at it, I was just like, okay, we got logs. So like, what do we know about log? And maybe we actually, like, you know what I mean, just multiply this equation by 2 and then subtract them, you know what I mean? And then maybe when we subtract, if we do, like, this is a property of logs. If you have like log base 10 of 2, and then you're going to subtract log base 10 of 4, that's the same thing as just log base 10 of 2 divided by 4, you know what I mean? And it's cool property of logs where, yeah, these were different. So that was the first strategy that, I mean, I don't know. I was just kind of playing around with it. But yeah, so if these two bases are different, and so let's say we do have like log base 10 of 2, and I want to switch this to log base 2, well, what I do is I do log base 2 of 2, the number that I kind of want, but then I have to do divided by log base 2 of this base, 10. And I think that's right, you know what I mean? But yeah, kind of a little property of logs. But anyway, that's not even what this problem, you know, sometimes you have to actually like figure out what they're actually wanting, you know what I mean? Because then the other property of logarithms, and I think it spells it out. Like, you forget which numbers are which. So if we just have like, I think you need to memorize. So and then it spells it out for it. You always say like, hey, log base 10. So let's do that. So we have base 10. Like, even right there, that gives us some information that if we had 10, hey, that's just our base, and then we would take it to some exponent. So this is log base 10. But now, I mean, what are logs? Well, they're going to give you the exponent. So, I mean, like, this is the exponent. And then, so that's the only thing that you have to memorize. First, log base 10. That's your base. And then what are logs? Well, they actually equal the exponent. They give you that and then so when you do this base times this exponent, hell yeah, sometimes you get a hella big number, you know what I mean? And so that hella big number goes right here. So let's just put not too big of a number, but 1,000,000. And I think this would be the best log to remember, that log base 10 of 1,000,000 is 6, which is saying if we have a base of 10 to the 6th power, hell yeah, we get a big number. You know what I mean? That's 10 to the 6th. That's 1,000,000. Cool. I'll write it. And cool, so now we can kind of move on. So now, like, this problem is just like, well, if we got this side to just be like some normal number, well, and this one to be some normal number, hell yeah, then we could multiply this one by 2, and then do what? Subtraction, where the y's would cancel, and then you could solve for x. Once you solve for x, you solve for y, and what they want is just like a generic 4x plus 5y. What the hell is that equal to? It's equal to 8. But yeah, I was just super happy that I was able to get there. Now the prerequisite for this is to for sure know, like, you know, even just like right here is like, what can we do to this? And even like right here, what can we do to this? You know what I mean? So we're gonna learn how to, you know, even just like, hey, the square root of 100. Don't think of it like that. Think of it as the square root. Sorry, the square root of 10 times 10. Sweet. And then you can think of this as the square root of 10 times the square root of 10. So that's kind of the first, I don't know if it's like a product rule of exponents, but, you know what I mean, an exponent, like if you do have something under the exponent that's 10 times 10, well, you can take whatever you're doing to each of those, which we just did. And you could even say, hey, this is 10 times 10 to the 1/2. That's also a good thing to do, because now we got 10 to the 1/2, 10 to the 1/2. And for sure. And then let's do it even. Let's say we had the square root of 200. You know, I mean, we could write this as 2 times 10 times 10, and this is to the 1/2. And even, like, I haven't even thought about this, but anytime that you just have a normal number, well, make it an exponent, you know what I mean? So this is 2 to the 1 times 10 to the 1 times 10 to the 1 to the 1/2. Now, how do we incorporate this 1/2 into this? Because now this is going to be 2 to the 1 to the 1/2 times 10 to the 1 times the 1/2 times 10 to the 1 times the 1/2. And then, so again, my question is, like, what do you do when you have a 2 to the 1 to the 1/2? Well, they say just like multiply those together. So we're going to have 2, but the exponent is going to be 1 times 1/2. And 1 times 1/2 is a half. And so you could carry that through. So obviously this is going to be 2 to the 1/2. You could do that same thing doing this. This is 10 to the 1 times a half. That's 10 to the 1/2. And this is 10 to the 1/2. Sweet. And it just happens that when you have 2 to the 1/2, and it's probably better written like this: square root of 2, and then you have square root of 10, square root of 10. Square root of 10 times square root of 10, that is 10. So we're just left with square root of 10, 10. You know what I mean? So that's kind of the prerequisites for probably this problem, is to be able to, like, hey, can you turn this into multiple numbers inside there, even 18? Like, and this one's spelled out for you. I mean, you really can't do much with it. You could divide by 2, sweet, and then it's going to give you 2 and 9. So heck yeah, right off the bat, we got 2 times 9 to the 5/4, and that's going to be 2 to the 5/4 times 9 to the 5/4. And I even had to do this one. This is the first thing that I did. I was just like, well, I don't even know what this means, right? And so, so I was just like, well, doesn't it mean 9 to the 5? And I was just like, okay, so let's do this one first. I was just like, isn't that just 9 5 times? Okay, sweet. But then we have to take this to the 4th power. So we'll get to that in a second. And this is just 2 times 2. We got to do that 5 times. That's what that 5 means. But then what does to the 4th power mean? Well, we know to the 1/2 power, if this was 5 to the 1/2, so it's like, make sure it's 5 times 5, 2 times 2, 5 times, right? That's what 2 to the 5th means. But this half would mean, hey, then you're going to take the square root of it. So let's do that. You know what I mean? That's not what this means. But this would be 8. What we're doing is 18 to the 5/2. And so once we took the square root of it, hey, this might not mean much, but hey, you can take the square root of each of them individually. And now when we get the square root, we know that if we got packets of 2 of them, heck yeah. Like, hey, these 2 just become 9, those 2 just become 9, and then we still have that square root of 9. Same thing here. These become, these become 2, that becomes 2, and that becomes the square root of 2. Okay, but we don't have that. We have the 4th root. We don't have the square root. So now, what do we do? Well, we have to have packets of 4, or you could say this. We have 4 square root 9, and I'm going to do this all 5 times because we got 5 of them. But only 4, just like 2 of these add up to 9, 4 of these add up to 9. You know what I mean? So you could, this could just be 4th root, I don't think I said that right, but and then 4th root 9. So that's how you could write this. So just a lot of different ways. This is 4th root of 2 times 2 times 2 times 2. And this is 4th root 2. So after we do this, you're going to have a 2, but then a 4th root 2. And what the hell is 4th root 2? Well, that's 2 to the 2 to the 1/4. Cool. So that's what we get there. And this is going to be 9 times 9 to the 1/4. Cool. And that's what we get there. But anyway, and then obviously this, we got one more of them, 4th root 9. All those add up to 9, but then we have still the 4th root of 9. Okay, hell yeah. So I think let's do this officially and grab a new sheet of paper. Okay, so I think we were on a roll with this one, you know what I mean? So we said 18 is 9 times 2, and that's going to be to the 5/4. This is going to be 9 to the 5/4 times 2 to the 5/4. And I think we get it, even from this perspective. But now, we have to look at, again, what this means, because it gives what a is up here. So we say log base 3 to the square root of 2. So that's going to be our base. We're going to have 3 square roots of 2. I don't like to write it that way, so we're going to write it 3 times 2 to the 1/2. And well, let's say this is 3 to the 1. So this is pretty nice to write it that way. Okay, so this is our base. And what's our exponent? That's what we don't know. So I do a little box, you know what I mean? I like a little box more than like writing an x. I think the x is like, I'm not going to solve this problem. But if you write a little box, it's just like, hell yeah, I could probably solve this problem. So anyway, so that's what we do there. So this is equal to that exponent. So we have log base a. That's going to be our base time to the exponent. You know what I mean? And this is going to equal this number. And we already kind of simplified it. So this is going to be 9 to the 5/4. I guess we can just write it in. 9 to the 5/4 times 2 to the 5/4. But hey, we don't have 9 over here. We have a 2 over here, but we don't have 9. So what can we do to this? Well, we can do that same thing. Hey, 9 is equal to 3 times 3. So let's do this on a side. So we're going to say, hey, this is 3 to the 1 times 3 to the 1 to the 5/4 power. Oh, well, isn't that just, and you can kind of forget the 1, but isn't that just 3 to the 5/4 times 3 to the 5/4? Sweet. So we're going to, I don't know if that's going to help us. I don't know if this is the direction I went, but you got 3 to the 5/4 times 3 to the 5/4 times 2 to the 5/4. Heck yeah. Oh, and this is cool, because I think we can do something here. I mean, let's say we just had square root of 2, square root of 2. Why does that work? Why does that equal 2 to the 1? Which is basically, because we have 2 to the half times 2 to the half, and that equals 2 to the 1. You know what I mean? What gives? Because isn't that just like, hey, 2 to the 1/2 plus 1/2? So that's the other property of, you know, if you got 2 to the 1/2 squared, well, yeah, then it's going to be 2 to the 1/2 times 2. That's going to be your exponent, and you're just going to have 2. You know what I mean? Basically, you're going to have the square root of 2, but square it. So that's what that is. You know what I mean? This, visually, we all know, but this is kind of the way you do it, you know, in fractions and exponents. And so I guess the same thing here. If we have the square root of 2 times the square root of 2, that's going to be equal to 2 to the 1, and you can easily see this, the exponents. So, so here we have 3 to the 5/4 times 3 to the 5/4. This is just going to be 3 to the 10/4. Okay, hell yeah. So let's throw that in. So we have 3 to the 10/4 times 2 to the 5/4. Now, cool. So we have this 3, and then we have this 2. Hopefully, when we multiply whatever we multiply, it just works. And it should, because, hey, we have 1 of these, and we have half of those. We have 10 of those, and we have basically half of 10. That's 5 of those. So now we just play the game of like, hey, and again, you can play the game on either one of these, because this, how do you write this? This is 3 to the 1 exponent of that times 2 to the 1/2 exponent of that, sweet, is going to equal 3 to the 10 to the 4th times 2 to the 5 to the 4th. So you actually have two different equations. You know, you could say, hey, this is 3 to the what is equal to 10 to the 10 to the 4. You know what I mean? And, okay, yep. So it is base, oh, where did I get 10? Okay, so we have 3 to the what is equal to 3 to the 10 to the 4. And so, oh, isn't this just 10/4? I don't know. Let's try it out. So yeah, I think box is just 10/4. So we have, let's try it. So we have 3 to the 10/4 times 2. 10/4 times a half is just going to be 5/4. Sweet. And so we have 3 to the 10/4 and then 2 to the 5/4. I don't know why I was slow rolling that, but yeah, it just spells itself out. Sweet. So we got our first answer, maybe? What did we get? Well, we got that this whole thing is equal to 10/4 because we found the exponent. Hey, that exponent was 10/4. And yeah, it's just like we don't deal with, I don't know, unless you're doing this kind of stuff, no one deals with logs on a daily basis. I don't think anyone does, you know, except if you're studying for these things. Just no one does. Guaranteed, like almost guaranteed, no one does. It's crazy. But it's just kind of fun to play around with them because they do have specific rules. And once you get used to them, hell yeah, you know something that no one else does. Okay, so that was tripping me out because all we were trying to find was the exponent and we found it. So this whole thing is just 10/4. You know what I mean? So keep that in mind. And now we're going to do this one. And I think we should do a new sheet of paper just to keep it fresh. Alright, we're going to do that same thing, but our base is hella crazy. So this, you know, what could we do to this? Anything downstairs can just be, so this is just going to be 5 to the negative 1/6. And this is going to be, hey, remember square root of 6 is 6 to the 1/2, but it's downstairs. So we bring it upstairs and it's going to be 6 to the negative 1/2. And now we can do that same thing. If we get this in the shape of that, now that we know what we're doing, now we can just be on a roll. And so this is our base, so log base this. So we're going to take this to that some power, and that's going to equal this square root of 1080. Okay, so these are the things that were, so the first thing is, hey, we need a 5. You know, at least one of them. I don't know, so we have to factor out a 5. I don't know how many 5s are in 1080. So the first thing I do, like I even did this, I was just like, how many 5s are in 100? Well, there's 20 of them. Cool. So how many 5s are in 1,000? Well, there's 200. Sweet. So I was pretty decent there. And then I was like, even if I didn't know how many 5s were in 80, how many 5s were in 100 again? 20. Okay, so how many 5s are in 80? Still don't know. 80 divided by 5? Like, how many 10s? So I would just say, how many 10s are in 80? Well, there's 8 of them. Well, how many 5s are there? 16. So that's kind of my methodology to not make mistakes on the simple stuff. And so, heck yeah, 216. So there's 216 5s. So if we factor out this, so this number is the same thing as 216 times 5. Sweet. And now we got to factor out a 6. So I had to do this long form, but I did 6 times 3 is 18, and I get 3 more. So 6 divides into 36 6 times. Hell yeah. But check this out. 36 also divides, this is 6 times 6. So we already divided once. So sweet. So we're going to get 6 times 6 times 6 times 5. That's this number. And then let's take it out of the square root, because hey, this is, well, it's the same thing as 6 to the 3 square root times 5. And again, remember our rules? Hey, this is 6 to the 3rd, and you still do this to the 1/2. You know what I mean? And then you could do 5 to the 1 to the 1/2. I wouldn't. I would just instantly see that this is 6 thirds 3 halves. You know what I mean? Times 5 to the 1/2. You should be able to see it like this, but it's just cool to do like every little step. So you know what I mean? You kind of know all the rules, because this is just going to be 6 3 times 1/2. You know what I mean? So that's going to be 1.5 or 3 halves, and then this one's going to be 5 1 times a half. Obviously, that's just a half. Hell yeah. Okay, so this is what we have over here. So now we have, so we're going to equate this to this. 5 to the negative 1/6 times 6 to the negative 1/2. Now, I'm sure people are supposed to do this problem in like under 3 minutes, but I don't know, we're doing pretty good. So now, I should get them 6 to the negative 1/2. Get them in the right order at least. Or since I have these this way. Okay, so now we can play that same game, and hopefully we just score. You know what I mean? So, and hopefully we didn't make any mistakes. Because we're going to say we still have to take this to some power. And again, that's 6 to the negative 1/2, just to spell it out. This is such an extra step, but now we have 5 to the negative 1/6 to that power, is equal to that. But you could skip that step and just say 6 to the negative 1/2 times whatever, and then 5 to the power of negative 1/6 times whatever is equal to 6 3/2 times 5 1/2. So we have two different equations in here. Hopefully they're both the same. We have negative 1/2 times something is 3/2. I like to do this. Hey, the 2's cancel. And so looks like our little box is going to be, and bring the negative 3. So let's try that one more time for this one, because it should, hopefully it just makes sense all around. Else the problem's messed up, you know what I mean? So, booyah. We could factor out a 2. This becomes 3. Okay, hell yeah. Bring the 3 upstairs and the negative, so we have box is equal to negative 3. Do whatever you need to do that, but sweet. Alright, so now that we know that this is going to be negative 3. That's pretty cool. And this was 10/4. Okay, so now we can just jive on the problem. So what we're going to do is we're going to multiply this by 2. So we're going to have 4, a 2 there, and then a 6 here. Because now we can just subtract, we can just add them. This is a negative 2y, this is a positive 2y. So if we add them, we get 7x. Cool. And then we add these. Now I made a mistake, you know what I mean? And it's just fascinating. I'll tell you that I just messed up this. I mean, I did this pretty good because I was just going to say, hey, this is equal to 10/4. That's a good place to start. But I would get this into something over 4. So 6 times 4 is 24. So this is going to be negative 24/4. Now the error that I made was I just, for whatever reason, I was just like, okay, 24 minus 10. And I did that. And I shouldn't do this. My new thing that I've been doing, and I probably not the only. It's just like I don't like subtracting things when they go negative. It messes with me. You know what I mean? So I'm going to do this: 10 minus 10/4 minus 14/4. And see how negative 10 minus 14 is 24. But now see how 10 minus 10. I think. Hopefully I invented this, you know what I mean? That would be pretty sweet to invent something, but it's, oh hell yeah. And then so we have, so negative 14 divided by 4, and I'm going to factor out a 7. So this just becomes x, and this becomes negative 2/4, or negative 1/2. Oh hell yeah, so we have x is negative 1/2, so we're done there. X is negative 1/2. I messed up and forgot that negative sign, and said x was 1/2. I would have got the wrong answer, and hopefully... probably no one would have gave me partial credit on this. I don't think you get partial credit. I have no idea. No, you probably do. Okay, but hell yeah. So we got x, and now it's just simple just to choose one of these equations to get y. You know what I mean? So let's do this one. 2x minus y is negative 3. And we said x was negative 1/2. So we're going to have negative 1 minus y is negative 3. So it looks like y is just positive 2. Sweet, because if y is positive 2, you still threw the negative, and negative 1 minus 2 is negative 3. Okay, hell yeah. So we got both x and y, and they just want to know what 4x is. Well, 4 times negative 1/2 is negative 2, and then 5 times 2 is 10. So plus 10, and we get 8. Hell yeah. I was pretty happy about that one. You know what I mean? This is probably one of my best videos. I dig logs. You know what I mean? It took a while for me to figure out like all the tricks. But I think, you know what I mean? This is cool. Like when you come back to logs, like when you just haven't done them for 2 years and you don't even know what they mean. Still, I would just say, hey, log base 10. Log base 2. What the hell is the base? That's going to be 2 to the something. And then, hell yeah, logs are exponential, so that something is over here. I like to write it as a box. I don't like to write it as like an x or like an xy, you know what I mean? Because I think they would do like log base 10 of y is equal to x. I have no idea. But if you do this box, I really like that style. And then just know that this is going to be your bigger number. So let's do that one again. So we have log base 10 of a million. Now, I probably wouldn't write it like this. I would just say log base 10, and then this is equal to 6. But I would say log base 10, and then be like, what's the base 10? The base is down below. And then what are we going to multiply it by? And then what are we going to get? And so, heck yeah. So I would start to write it like this, and then the last thing I would do is write this number. I think the number right here is probably the most confusing part. You're just like, what's the number right there? And so it's going to be 10 to the 6 is equal to a million. And that's the number you would put right here, 1 million. And it's kind of a weird thing because you could even write 10, you could even write log 10 to the million. So we'll do this. Million is equal to 6. This is the same thing as writing 10, log 10 to the 10 to the 6 is equal to 6. And I think that trips you up. You know what I mean? Kind of messes with, because you're like, what is this saying? This is saying 10 to the, whoa. No, it's saying 10 to the 6 is 10 to the 6. Okay, I got it. And so sweet. Oh yeah, I think there's a rule in here, but I gotta end this video. I don't really know the rule, but obviously, yeah, you can take things outside, or I kind of forget how that works out. But anyway, I was pretty satisfied with this one. So thanks for joining me, and guess what? That's a video.